Okay, let's talk about the derivative as a function. Now, before we looked at finding the derivative of a function at a particular value. Now we're going to do this in general. Somebody's going to hand us a function, say f of x is x squared, and we're going to derive a brand new function that spits out slopes of tangent lines to the original function. And that's called the derivative. And in this video, we're going to do all these using the definition of the derivative, which is right here. You should probably have this written in your notes. You're going to be doing this a lot. Later on, we'll learn a bunch of shortcuts, a bunch of derivative rules, but for now, we're using the definition. Okay, so we've got this guy here. So that's our original function. And maybe we can graph a quick sketch here. We know that square root of x looks like that. Then his derivative, f prime of x, equals the limit as h approaches 0 of f of x plus h minus f of x all over h. That's our definition of the derivative. So that will be limit h approaches 0. F of x plus h means take the original function and every place you see x, now we write x plus h instead. So that'll be square root of x plus h. That's just this. Then from that, we subtract the original. We subtract f of x. And notice this is a fraction that's over h, so this needs to be a fraction over h. And notice we're going to keep writing limit all the way down until we finally take the limit. So limit as h approaches 0. All right, now remember when you're finding a limit, ideally you would just like to plug in your value. I would like to plug in h equals 0. But if you do that, you can check yourself, you get 0 over 0, which is undefined. So somehow we're going to have to make this h cancel out. And on problems like this with these radicals, the trick that we use is multiply top and bottom by the conjugate of whoever has the radical. So I'm going to multiply top and bottom by the conjugate of this, meaning leave the first guy alone, change the sign of the second one to plus root x. And I have to do that top and bottom, otherwise I'm changing the problem. I'm really just multiplying by 1. Now, I see this happen sometimes. Could we cancel this out? Could I do this? Absolutely, I could, but then I'm just right back where I started. So mathematically, are you allowed to cancel it? Sure. Should you? Absolutely not. That would be a waste of your time. Now we're going to FOIL on the top. Leave the bottom factored. Trust me, I know from experience. Leave that factored, but FOIL on the top. So first, square root of junk times square root of junk is just junk. Then the outers. I'll actually write it out here. We get plus root x times root x plus h. Then on the inners, we get the same thing, but with a minus. Those are going to cancel. That's why we use the conjugate. That's why this trick works. And then last. So that was first, outer, inner, last. Root x times root x would just be x, but I've got a negative times a positive, so I'll get a minus x. And then let's rewrite the bottom. Okay, we get a bunch of cancellation. These middle terms just cancel out. That's going to happen every time. And in this case, these x's happen to cancel out. So I get limit as h approaches 0 of h over h root x plus h plus root x. Oh, look, the h is canceled. That's going to happen every time we're finding a derivative. So this is just limit as h approaches 0 of 1 over root x plus h plus root x. Now I can actually take the limit. Now that I've canceled the h out, I can plug in h equals 0, and I'll get 1 over root x plus 0 plus another root x. That's just 2 root x in the bottom. So I get 1 over 2 root x. So my original function is square root of x. His derivative, a brand new function, is 1 over 2 root x. This guy will spit out slopes of tangent lines to the original function. So for example, like it's not part of the problem that was asked, on f of x, f of 1, for example, will be square root of 1, which is just 1. So that's that point right there. That's on the original function. That's just a y value on the original function. The derivative at that point would give me the slope of the tangent line at that point. So let's draw that in blue. So the tangent line will just come in and just touch the graph at that one single point, just barely kisses it. The derivative tells me that guy's slope. So f prime at 1 would be 1 over 2 root 1, just plugging in 1 here, which is 1/2. So this blue line, the slope of that blue line is 1/2. So back in the previous videos, if we wanted to find this slope, we would have found the derivative at the point 1. Instead of x everywhere, we would have had the number 1 everywhere. This is much better because now I've got myself a brand new function. And if now I want to find the slope when x equals 7, I don't have to go through all this work again. I've got a function. I would just plug 7 in here and I'm done. I've got the slope when x equals 7. Okay, let's do some more. So here, f prime, let me switch back to my black marker, is by definition the limit as h approaches 0, f of x plus h minus f of x all over h. By the way, I'm going to have you guys write up a bunch of these. Like you've got written assignments, you've got test questions. This is the proper way to write this up. Everything you see me writing is required. You have to start with this. This is what we're finding. It's required that you write this down. It's required that you write limit as h goes to 0 at every step until you take the limit and so forth. Everything you see me writing is here for a reason, and to get full credit, you got to write that yourself. Okay, so x plus h. I'm going to take my original function, and every place I see x, I'm going to write x plus h in parentheses. So that's just this part. That's all I've done so far. I'm supposed to subtract from that the original function. And then notice this is a fraction, that's over h. This has to be over h, otherwise this equal sign is not true. Okay, so let me do a little color coding here, just to make sure everybody sees what's going on. These are the same. And then maybe we'll use green. This was f of x here. And then h is just h. Okay, now we clean this up. Limit as h approaches 0. X plus h squared. Maybe we'll do that over here as some side work. That means multiply it by itself. It is not x squared plus h squared. Squaring something means to multiply it by itself and FOIL. So we'll get x squared. For the outers, I get an xh. For the inners, I get an xh. So that's 2xh. And then last, h squared. You're going to be doing that so many times that you're just going to memorize this. X plus h squared is always going to be x squared plus 2xh plus h squared. Let's distribute this 2 minus 2x minus 2h. Distribute that minus. Notice minus, minus, I get a plus 2x. And don't forget the over h. If you've done this properly, everything after that minus will cancel out. If you have a polynomial here, if your function's a polynomial, everything after this minus will cancel out every single time. See, look, x squared, negative x squared, 2x, negative 2x. Everything that's left on top will have an h in it. If you've got something left on top that does not have an h in it, you've done goofed. That's a plus right there. Let me fix that. See how every term on top has a factor of h. So that's our next step, is factor out that h. That's a plus again. And then at this step, the h will cancel every single time. Limit as h approaches 0, 2x plus h minus 2. And now finally, at this step, I can actually plug in h equals 0. So that'd be 2x plus 0 minus 2, which is, I've run out of room. I like to keep this all lined up. This really should go here. Maybe I'll make it a little smaller so that I can do that. (2x minus 2). So after all that work, we have now shown that the derivative of my function is 2x minus 2. Now, I've said this in previous videos. A lot of people will skip this step here. They won't write it out. They'll do the factoring and the canceling in one step. They'll go straight from here to here. That's perfectly fine. Everything else here is required to get down to here. I just wrote this for completeness. That this is a chain of equal signs here, and it says exactly the same thing. Let's pause.